So like I've said a couple times now, the computer output route is the most popular that I've seen on AP for the multiple choice and the free response. So we really want to make sure we see a lot of practice problems where we're just identifying the appropriate numbers and making the correct statements based off of these numbers. So that's the first example we're going to see. Oops. Okay, so right here what we're going to look at is, does a positive relationship exist between high school GPA and freshman year performance in college? A random sample, that'll probably be important later, of 40 freshmen, that will also probably be important, that's my N, at a local college was taken, and their high school GPA and their GPA from their first full year were recorded. So you'll see here we were given a lot of information. We have the computer output, so these are the actual numbers. We have the normal probability plot. So this is something that we've done a couple times in class. Scatter plot, so this is the raw data, and the residual plot, so these are the errors. So it's asking us to perform a significance test and complete a 90% confidence interval. What we're just going to do right now is the significance test. Okay, so let's go ahead and just jump right into it. For a significance test, we're going to start with state. So I want to state my hypotheses. So my null hypothesis is that the slope is 0. I always have to define my parameters. So what is B1? Well, B1 is the slope of regression line for the true relationship between what? Well, what variables are we talking about? We're talking about high school GPA and freshman year GPA is what those stand for. So I'll just abbreviate them the same way, high school GPA and freshman year GPA. I'm just abbreviating them the exact same way that I see them out there. If you would really like to, you could write those out in words. Okay, so my null is that there is no linear relationship between these two variables. My alternative is that there is. More specifically, my alternative, I want to know, looking back at the original problem, does a positive relationship exist? So is that slope positive? Okay, so now that I've got my hypotheses taken care of, we want to look at all of those conditions. So the conditions, the acronym that I showed you was SIREN. I'm going to talk more about the conditions, but I don't want anybody worrying too much about those. The majority of these inference tests have so much else in common as far as state your hypotheses, which calculations you have to report, and what conclusions to draw. That alone will get you so many of the points that if you forget a few of the conditions, it's not the end of the world. You can still perform above average on these free response questions. But since this is our first problem with those conditions, let's see what they look like. First, if we're going through these, again, the acronym is SIREN. Okay, so straight, that's the S. So let's look at the regular data. Data is approximately straight. right? And condition 2. Condition 2, I want to know, are the samples independent? Well, the way that I show if they're independent is by if they were randomly selected. That's one of the ways. And it just so happens that in this study, it was a random sample. So I'm just going to kind of lump condition 2 and condition 3 together. And that's pretty typical here of these problems. So this is going to say random sample stated. So we can assume the 40 freshmen are independent of each other. Okay, that takes us into condition 3. Condition 3, that's the E, so equal spread or variance. Now, we'll notice here on my scatter plot, so I'll just use this. So notice here on the scatter plot that I don't actually have the line, so it's kind of hard to tell if they're spread out equally about the line. And so since I can't get a great idea of it from the line itself, so let me just draw that, what I'm saying is I have not been given my regression line. I don't know if it fits up here, or if it fits up here, or if it looks like this. And so I can't really determine if the spread, if the variance is equal. But I have my residual plot. The residual plot, if it's got no pattern, then we're fine. That tells us that the spread is approximately equal. Okay. Oops. Okay, so I'll just say no pattern in residual plot. So we can assume approximately equal spread. I'm going to go ahead and use the vocabulary word, variance. And lastly, the N. So N is normal. Okay, for here, I want to look at, are the residuals approximately normal? Let's jump back up to our original conditions. So we checked straight, independence, and random, equal variance or spread. Now I want to know, are the residuals unimodal and roughly symmetric? Well, I said we would see a couple different ways that we can show that. And one of them, you may have a guess, is by looking at the normal probability plot. So here we're graphing the residuals by just a standard axis over here, so normal quantiles. And that's just kind of like a variation of like standardized standard deviations. Don't really worry about that too much. Just know that we've graphed the residuals along here, and we want them to be approximately linear. So here we've got some that go around a little bit a little bit underneath, so they've got negative residuals. Some that get a little bit closer, so they've got slightly smaller residuals, and then we've got some that would be right around where they're supposed to be, right there through the line. That would be a residual of 0. And then we've got some that are a little bit above the line. Okay, so again, normal probability plot, all we're looking for is approximately linear. So that's what we'll do for condition 4. So we can assume the residuals are approximately normal. Okay, and you guys are probably used to the state step being the longest at this point. We've got our hypotheses, we've defined our parameter, and we checked our conditions. So next, it's time for the plan step. Okay, so our plan is just stating lin, reg, t-test. That's what we ran, or that's what the computer ran. So on to the do step. The do step, I think it's just helpful. This is just force of habit. I'm going to state where I'm getting these numbers from. So using the computer output, let's go ahead and look at the computer output. Okay, so this computer output is broken down very, very similarly to the age of wife, age of husband example we just saw. So freshman year GPA, that's what we're trying to predict based off your high school GPA. So that's my Y, that's my response variable. And then high school GPA down here, that's my explanatory variable. So just like before, our constant, that's our y-intercept. Our coefficient in front of x, that number in front of x, if we're thinking back to y equals mx plus b, little algebra review, that number in front of x, that coefficient in front of high school GPA, that's our slope. That's B1. Oops, that's kind of a sloppy B1. That's a little better. Okay, so we've got B1 and B naught. And while B naught is useful, the standard error of B naught and the t-statistic for B naught and the p-value for B naught are not. And let's think about that in context. So a high school GPA of 0. So a high school GPA of 0, realistically, that student or that individual did not make it beyond high school. So they probably will not have a freshman year GPA that we'll be able to predict or even actually observe. So a high school GPA of 0 doesn't really make sense. We wouldn't really want to use these values to test anything to do with the y-intercept. But that's what those are there for if we ever do. So standard error, this is going to be SE of your slope. This t-statistic, that's our t. Our p-value, and then finally it's nice to record r squared and s sub e. Fantastic. So we've got all 3 of the things that we know we need to report. We're able to do that. So I'm going to record my t, my test statistic. I'm going to record my p-value, that's 0, and then we'll talk about degrees of freedom. So down here, using the computer output, my t equals 5.333. My p-value is so small, you'll notice some of the values that we got in the last unit where it was like 1.6 times 10 to the negative 4 or 10 to the negative 8, those really, really small numbers. Well, your computer, just like the calculator, can't really function with numbers that are that small, so p-value is just 0. If you just want to put 0, that's fine, because that's all we know it is, and so we can safely assume it's going to be less than whatever you decide to set your alpha to. Finally, your degrees of freedom. For degrees of freedom, we need to look back to see if we were provided with a sample size. So our sample size, which we recorded at the very beginning, is 40. So degrees of freedom is n minus 2, n minus 2, 40 minus 2. I'm going to report degrees of freedom. Oops. As as 38. Okay, we are ready to draw our conclusion. So our conclusion, like I alluded to just moments ago, will be we reject the null because p-value is less than any reasonable alpha, or any reasonable significance level. So we have sufficient evidence. We found enough evidence that there is a positive linear relationship between high school GPA and freshman freshman year GPA. Okay, this, just depending on the year of the test and what else they're asking you to do with this question, may be worth full credit. But even when anytime you're describing a scatter plot, positive linear relationship, it really helps to elaborate. Well, what is the positive linear relationship? What does that mean? Well, it means as high school GPA increases, freshman year GPA increases. That's positive. As X increases, Y increases. And that's it. This, oddly enough, is the most common, at least I think it's odd, it's the most common chapter 26 problem, is being able to interpret this table. And that's because, again, guys, like, statistics in the real world is very software driven. A lot of the things that we learn how to calculate by hand can be done so much faster. So it's what do these numbers tell us about the data, and interpreting it and understanding what a p-value is and what to do with it. So for this chapter, understanding these tables are going to be very, very crucial. When I return, we will see an example of creating a confidence interval from either these tables or by hand. But until then,